Hello everyone. Today we are going to start with chapter 4, Software Concepts, PUC first year computer science subject. So in this chapter we are going to study about different types of software and the basics of different operating systems. So here computer is basically, if I want to say that a complete computer system, then it needs three main things. One is hardware, software, user. Hardware in the sense physical parts, physical devices of computer are called as hardware. And software is one special thing which makes the hardware to work. And users are the people who uses computer to do different operations. That is what users. So here hardware consists of physical devices and their interconnections for the purpose of storing and executing a program. So following diagram, you can see pictorial diagram, what all require to say that it is a computer system, hardware, software, and user. Software in the sense what? It's a collection of programs, collections of programs and related data that provides the instructions for instructing a computer what to do and how to do it, right? So here it is something like software is one special thing which makes the computer hardware to work. How it will make it to work? Because it contains set of programs. Each and every program contains set of instructions, where every instruction will be instructing the computer to do some particular operation. Those group of instructions which are written in a systematic manner to perform a particular task. Right, every program performs one task. Like that, collection of programs makes group of tasks. Right. So by using all these programs, they instruct the computer, or they are going to specify, they are going to tell to the computer what to do and how to do it. Both it is going to specify. Right. So here we have an interesting example. So the processing of information in human brain. You take example of human brain. Even human brain is also like computer, so that you will come to know how it will process. See, for example, assume that some fellow to whom you have met a very long period of time back, right? After a long gap, once again you met that fellow. Immediately you will say that you were in that school, no? You were studying in that section, no? Like that you'll say. That means very long time back, right? That fellow was studying in your school only, right? You are not having direct touch with him, but he was in your school, right? So, but after some period of time, you are meeting that fellow once again and you are recalling that information. How it is all possible? Who is trying to recall all that information? Where the data is stored, right? This all, if you think, it is all the work of human brain. So human brain consists of neurons, and neurons are interconnected with each other. We can say our brain is a massively parallel processor, right? Massively parallel processor. Parallel processor means what? At the same time, it will be doing multiple work. The process of recalling a face which a person may not be seen since the last 30 years is very complex task requiring lots of comparison among similar faces and images stored in his mind. During this last 30 years period, you have met many peoples, right? Maybe many of the people's face is a little similar to this fellow, but in all those faces, how your brain is making valuation that yes, this is that person only, right? So that is why we say our brain is what? It is a massively parallel processor. At the same time, it will be handling multiple works. Similarly, see, whenever same person will say a long time back, say a fellow who was in touch with you, but after a long time you had a like gap. So when they make a phone call, once when they call it, your brain will start analyzing their voice. Based on their voice, the way they talk, your brain will start analyzing his face. Sometimes in the phone, they will be asking, can you recognize me? Are you getting, can you remind, are you getting like how I was, like that? Some points they'll be asking, right? So this is all done by your brain. So our brain can store approximately 2 raised to 44 bits of data. 2 raised to 44 bits, right? So software is what? It's a set of programs, procedures, algorithms, and documents concerned with the operation of a data processing system. This is the definition of software. There are two types of software: system software and application software. System softwares are those which are designed to perform the operations of the computer, right? They are designed to perform the operations of the computer so that computer should function properly so that I can do my operations in my computer. If system softwares are not doing their work properly, you will not be able to do your operations in the computer like letter typing, gaming, hearing music. That is all not possible. It is system softwares are something like if your body is functioning properly, then you can do all your studies, gaming, everything you can do properly. If some of your body, parts of your body, if it is not functioning properly, you'll not be able to do your regular work, right? So the system inside your body, which is making you to do your works, that is a system software in your body. In the same way, in the computer also, there are system software which will be it will be making all the computer parts to do their functions properly in a proper time so that you can carry out your own operation. Such softwares are system software. This is general meaning. Let's see in your textbook what points they have given. The objective of system software is to efficiently perform the functions commonly required by most of the users, right? In order to achieve this objective, these programs are generally written at the machine level using instructions for addressing various registers of the central processing unit. Usually system softwares are written in binary language. That is nothing but machine level language using instructions for addressing various registers of the CPU. So the systems of the some diagram is there, but it's not visible here. I'll see. I'll try to extract it from other textbook. Later on, I'll update. It is a hardware dependent and not portable. The system softwares are hardware dependent and not portable. See, for example, in Apple mobiles, you use operating system iOS. Can you make that iOS to work on Android phone? Not possible. They work only for Apple phone. That's why it's called as what? Hardware dependent. Right. So portable in the not portable means what? Here also in the computer, some system softwares are not portable. That means some system softwares are designed to work for particular model of the computer, right? They won't work for another model of the computer. That is called as what? Not portable, right? That means system software developed for a particular model works only for that model. It is not going to work for other models. So that means it will not be a general purpose operating system. It is for the particular model of the computer. Then input output operations are generally performed by system software. And these softwares provides a convenient environment for program development and execution. That is software development. So programming languages like assembly level language, C, C++, Visual C++, Pascal are used to develop the system software, right? So to develop the system software, we use all these programming languages. So the final definition of the system software is a collection of system programs to perform common tasks which is required by every user. Coming to application software. See, whenever we buy the computer in the home, in the office, in the bank, anywhere, say assume that your neighbor, right, your friend, in their home, they have purchased the computer. We ask him, you have purchased the computer, no? What do you do with that? They'll say that, no, in college we have computer subject, no? There we have 200 students, but we have 10 computers. So we don't get sufficient practicals. That is why I have taken computer so that I can do all practicals satisfactorily. When I go to the office and ask them, sir, why you are using computer? They say that, no, we are doing all our official work in the computer itself because we can do all work systematically and fast. When I go to the bank and ask, so why you are using computer means they say that, no, we are maintaining all our accounts in computer itself and it gives us fast and accurate results. That's why we are going with the computer. But no one will say that as in our home, money was made more. That is why we bought one computer. Simply just for investing the money. We are not using computer for any other purpose. Will it be like this? No. Right. Computers are always purchased. See, computer is not a toy to purchase. Computer is always purchased by having some intention. I am using computer for education purpose. I am using computer for accounts purpose. I am using computer for official work. I am using computer for gaming purpose. You have some purpose and you buy the computer. So to complete all your purposes in the computer, you require set of software. Those softwares we call it as application softwares, right? So these are user-oriented programs. So application software consists of user application packages such as payroll, inventory, financial accounting packages. Application software is generally written in high-level programming languages. These are custom made as per the requirement. It will be. Although many general packages are also there like word processing, database management, spreadsheet, which are used by millions of users all over the world, right? MS Word, Excel, PowerPoint, Access, right? And Google Chrome. So many of the softwares which are used by millions of people all over the world. These are general software. The software which is there for a bank. So what happens? That software is a custom made software which is suitable only for that bank, not suitable for another bank. So being hardware independent, these are portable, right? Being hardware independent, these are portable means what? These software can be used on any model of the computer. Examples of application software: Microsoft Office, OpenOffice, Oracle, Sybase, Informix, Ingress, DB2, Tally, etc. System software is of three types: OS, operating system; language translators, that is assemblers, compilers, interpreters, linkers, loaders, and utility software. Three types of system software. Let us go with the operating system. The operating system is very important for the computer. In the beginning of the syllabus itself, we have discussed system software are very important. So suppose if system software is not there in your computer, how it will be? Say for example, a bike is there. If there is no petrol in it, what do you do with that? Right? Without petrol, it won't move forward. So in the same way, our body runs on operating system. You know what is that operating system? Oxygen. Without oxygen, our body won't work. In the same way, for computers, we require operating system. Those operating systems will make the computer to work properly. Without this, computer is like a set of plastic boxes. There is no use at all. Operating system is very important. Think in your mobile, if there is no Android, what do you do? Your phone only, it will not start, first of all, right? So when Android is working properly, then only WhatsApp, Facebook, Twitter, Instagram, and all it will work. Otherwise, it will not work only. So Android, iOS, these are all what? Operating system in your mobile. Similarly, in computers, we have other operating systems. So currently, I am demonstrating through computer. So my computer is using Microsoft Windows. So that Windows is also about operating system. An operating system is a set of program modules which provides a friendly interface between the user and the computer system. Computer resources such as processors, memory, input-output devices, and information, that is files. So OS manages these resources, right? Resolves conflicts and tries to optimize the performance of the system, right? See, for example, in a bank, a manager; in a school, principal or headmaster, right? These people plays a very important role. In a bank, in a school, that principal; in a bank manager, he will see to that the bank operation should be moving properly, right? School principal will see to that all teachers should be taking classes, all the tests, assignments, exams should go in time, results should be provided in time, sports should be conducted at the right time, and library should do their work. And like this, all the events handling properly on time, they have to be conducted. That all coordination between all these departments will be handled mainly by principal's instruction. Like that, operating system in computer. Operating system will make the coordination between all the resources, that is all the parts of computer, and it will make the computer to work properly, right? So that you can do your operation, right? So now here, OS manages these resources, resolves conflicts, and tries to optimize the performance of the system. Generally, part of the operating system, generally OS will be in the memory and supervises execution of all the programs executed on the computer. The user communicates with the computer through OS commands and program instructions. See, for example, I want to start a paintbrush. How do you start? Will you say, computer, start paintbrush? No, you go to the start button. This is a command or instruction. And here you type paint and you press enter. Paint is a command. When you press enter, you are telling the operating system to start the program. Like this, you are not communicating with the hardware directly. That provision is not there. You have to communicate through operating system to take all the services of the computer. That is only what learning the computer courses. Now you are all learning computer science in your course. Similarly, in the institutes also, students will be learning the computer. That means what? They're all learning the various commands to give order to the computer to achieve different results, right? So it plays a very important role in loading the program from disk into memory, displaying messages, translating programs, and in outputting results. All it will be done by computer OS only. Basically, it executes the user programs without letting the user bother about the detailed steps involved in executing them. Right. See, I just said start and I typed paint and I pressed enter. Paint program came on the screen and I'll start doing the painting. Do you worry how that paint program got started? What all the set of instructions are written to start any program? When that paint is started, in that you are doing drawing. Behind that doing drawing, how many thousands of lines of commands are being written and they are working? So we are not bothered about it. That thing will all taken care by OS, right? So you can see here, there is a diagram where the very innermost part, we have all hardware parts. In the next layer, we have system software, that is OS and utilities. In the outer layer, we have application software which are used by you, right? That is 3 layers of system they have given. So some examples of OS are Unix system, Unix operating system, which is a multi-user, very secure operating system. And the latest version of Unix nowadays, we are using Linux. Linux is very much used by the hackers, right? For ethical hacking, white hacking, gray hacking, right? Gray hat hacking, like this. OS bar 2, Linux operating system, Sun Solaris, MS-DOS, Microsoft Windows, right? Like Windows 95, Windows 98, Windows 2000, Windows NT, Windows XP, Windows Vista, Windows 7, Windows 8, Windows 2000 Server, Windows 2003 Server, 2008 Server, .NET Server, Android, Mac OS, nowadays Windows 10, Windows 11, they're all operating systems, right? So so the definition, if they ask you what is operating system for 1 mark question, an operating system is a set of program which acts as an interface between the user and the computer, right? So now here, let us discuss what are the terminologies used with the operating system. The first one is computer languages. Where in this computer languages, here, language means what? See, even we too use language to communicate with another person, right? See, the people who can't talk, what they do, they use symbolic language. That is also a language. Who can talk? We use English, Kannada, Hindi. We use various languages for communication, right? In the same way, when you want to communicate with the computer, you need a language. So that language, we call it as computer languages. If we have to communicate with the computer, we need one suitable language which can be understood by the computer. The computer doesn't understand your verbal command, right? Like how you talk with another person, in the same way, you can't talk with the computer. You can't make the computer to do the operation with your verbal commands, right? So you need one language through which you can give the commands. So such languages, we call it as programming language or computer language, right? Using these languages, user instructs the computer what it should do, what it should do. So programming language definition, if they ask for 1 mark question, it is a set of rules called syntax which user has to follow to instruct the computer what operation to be performed. Now there are two categories. One is low level language, another is high level languages. These are the two categories of programming languages. So here we have, in the low level itself, we have machine level language and assembly level language. And in the high level languages, we have general purpose high level languages like basic Pascal, C languages and all. And we have specific purpose high level languages like COBOL, Fortran, C++. Let us go through the machine level language. See, machine level language or a machine language is the only language of the system. That means computer understands only binary digits, binary language. That is only, we call it as machine language. Only these things it can understand directly. It doesn't understand English, it doesn't understand any other language. These instructions are externally represented, right? It understands only machine language, but externally they are represented in the form of 0 and 1, which are stored internally as a sequence of voltage levels. Voltage levels, right? Last chapter we had studied pit and land, clock signal, right? In that we have studied how voltage levels are represented in the form of bit and line, right? Digital clock signal. So it will be stored as a sequence of voltage levels, high or low, right? High or low in the primary memory, that is RAM only, right? Because RAM is the only memory to which the CPU will be interacting. As a general programmers come across many difficulties such as remembering of such large sequence of zeros and ones, which is very difficult to program, debug. It requires a lot of experience, knowledge about the internal architecture of the system. See, earlier we were using machine language to develop the software. So here what happens is all the C, for example, recently in the third chapter you have learned how like okay, how a letter will be means you have learned different conversions. Here I'll try to show you, right? So letter A, right, equivalent ASCII code, no, not ASCII code, equivalent binary number. See, when you write a letter A, its ASCII code is 065 and its binary like equivalent number is 0, 1, is 5 zeros, then 1. This is the binary equivalent of letter A. That means when you type a letter from the keyboard, ASCII, some electric pulse will be generated. That every electric pulse represents some ASCII code. That ASCII code for letter A is 65. 65 is a decimal number. So decimal to binary conversion, by using that format, 65 will be converted to binary digits. And that binary digit will be saved into the memory, into the RAM, in the form of sequence of voltage levels, right? So that means what? For writing a letter A, you can't write A or you can't write 65 in the binary language. You have to write this one. Now you think, if you want to write apple, right? Then what all the things you have to do? You have to write 8 digits for A, then 8 digits for P, another 8 digits for P, another 8 digits for L, another 8 digits for E. That means for 5 letter, 5 8s are 40 binary digits, 40 binary bits you have to write. Just for writing 5 letter word, you are writing 40 digits. Now you think, if I want to write this paragraph only, then how many binary digits you have to write? One is writing problem. Another is what? Remembering all those digits in the form of binary is not easy. It is very difficult, right? That is another problem. While writing, assume that somewhere in place of 1, if you write 0, then how you will make the correction? Suppose if a page containing completely zeros and ones, and I want to find out some mistakes is there in that, how to find out? I have to mark 8 digit and I have to check this list. Right, in that place, what I wanted to write, what is its equivalent binary code, whether I have written that binary code or not, that I have to check. And like that, you have to check the entire page. That is not easy. And always only one page of binary digits will not be there. Maybe sometimes 1,000 pages will be there. How you will identify the mistakes? It's very difficult, right? We can do it, but it's very time consuming. That is why here, right, in spite of all these odds, in spite of all these disadvantages of this machine level language, one point you remember, this is the only language which will be understood by the computer directly. Hence, even though these all problems are there, this is the fastest language which can be understood by the computer, because translation is not required, because you are communicating with the computer directly in the mother tongue of the computer, right? So we can program each bits and bytes. But one more problem is there. To learn this machine level language, to write programs in this, one should have a detailed knowledge of architecture of system. Architecture means the internal electronics, what we have, hardware, you should know in detail, right? So that is why these languages are suitable for technical students who are learning engineering and diploma computer science or electronic students. And these are some digits, some commands. If you write this, it's a command for loading the data. And this one says that add the content. These are the set of binary digits to store the result. And like stop, like this set of the like this binary digits codes will be there for doing different operations. So 4 bits, the first 4 bits represents op codes denoting what kind of operation has to be done, right? That is action, such as load, move, like that. Last 8 bits represents the operand denoting the address where the value is stored. So advantage of machine level language is what? These are the machine languages. Instructions can be directly typed and executed, and no compilation or translation required. Drawback already you have seen. This is machine dependent. That means it is not portable program, and it is difficult to program, modify, debug errors. That is why one more kind of language got developed called as assembly level language, right? So in the by seeing the disadvantages, drawbacks of machine level language, that led to the development of new programming languages which uses symbolic instructions called as assembly level language. What they do in this? So here, instead of writing all the codes in the form of a binary, so what they did is they gave symbolic codes. They gave symbolic codes, means what? Symbolic codes written in a English language, right? So English means we are all very much comfortable. We can write easily, remember easily. There are any mistakes, we can identify it very easily, right? That is all there. So we felt very easy to write the commands using this assembly level language. Those symbolic codes which are provided in the form of English word, they are called as what? Mnemonics. See there? Mnemonics they are called as, right? So earlier in the machine level language, what these codes were there in binary, now they are all replaced by English words, which is very easy to write. So English like words, right? But the problem is computer doesn't understand English. So these mnemonics have to be translated to binary language so that your computer can understand. And that is done by one external program called as what? Assembler, translator it is, which translates assembly level language mnemonics to binary. What are the advantages? Easy to code, easy to remember the command, easy to write, easy to find the error because all it's in English, right? Easy to modify. Drawback is what? It's a non-portable language. That means program written in one model of the computer will not work on another model of the computer. It works for only particular model. That is a problem. Say for example, assume that there is a machine Intel Core i3. In that, whatever the set of mnemonics are there, which will not work for other model of the computer. That is the main drawback. So assembly level language definition is what? It's a symbolic language in which mnemonics are used to code operations and characters are used for address. So the problem what we saw is, once again, to learn this assembly level language also, you must have a good knowledge of architecture of computer, right? That means these are the two languages which cannot be easily learned and programmed by a general student who is a non-technical student, who is not an engineering or a diploma student. For them, it is very difficult for learning these two languages. But the software companies wanted to have a student, right? They want to have a software engineer from any field, whether he's engineering or non-engineering student. Why? Because they want talented people. It is not that only engineering students have a talent. There are many talent students even in BA also, because many of the BA students also clears IAS exams. So they wanted some programming language which can be learned by all kinds of students. which are belongs to all kinds of fields, right? Such kind of languages they wanted to have. So by seeing the drawbacks of previous two languages, they developed high level languages, right? Where these high level languages are developed to overcome difficulties of low level languages. They are English like languages, means commands are so simple, right? Commands are so easy to remember, write, and identify mistakes and modify everything easy. And one more special point is what? High level languages are portable languages or machine independent. That means what? Programs written in high level languages are not related to any of the hardware system what you have in your computer. Hence, the program written in one model of the computer can be processed on any type of computer. That is why they are called as a machine independent or highly portable language. Right. So HLL, high level languages like Basic, COBOL, Fortran, Pascal, C, C++, Java, all these latest whatever nowadays we are having, everything comes in that. What are the advantages? They are machine independent, easy to learn, easy to write, easy to modify, easy to identify mistakes, and you don't require any knowledge of architecture of computer. Even though if you are seeing the computer, if you know very little about the computer also, directly you can learn this language, right? High level programming language. So whatever the disadvantage, high level languages lacks flexibility because the features of HLL always occur are not under the control of program. That means what features will be continuously in research, they'll be keep on changing, right? HLL is slower in execution to the generality of the statement, and that they are portable between different machines, but with a suitable compiler, right? See, it is as I said, in one model of the computer, when you are writing high level language program, it can be executed on all machine, but conditions apply. What is that? So in all those different models of the computer, there must be a suitable compiler over there. That means if the program developed in Windows, if I want to execute in the Apple laptop, directly it will not work. There we need a suitable compiler. So HLL requires translator because you are writing in English. Computer doesn't understand English, right? Computer doesn't understand English. So here it has to be translated to binary language. So we need a translator. We have two kinds of translator for this, compiler and interpreter, that we are going to study in the next topic. So this translator reduces the execution of the program because it is not understood directly, right? Assume that you are communicating with some person who is a Japanese person and you know English, but that fellow doesn't know Japanese. But in between both of you, there is one more fellow who knows English and Japanese. Now what happens? Now you speak something in English. This mediator should understand what you said. Then he has to translate it to Japanese and he should explain it to Japanese person. And Japanese person, when he says, this fellow should understand mediator, then he should translate and he should tell it to you. If the communication is like this, automatically slow. Assume that if both of you know some common language and if you are communicating directly, then communication used to be faster. The same case is there here also in the high level. High level languages are very flexible, which can be used by everyone. But the problem is what? Here, these are less efficient because translation takes more time. Automatically execution will be very slow. But there is no other way. We have to use these languages. Language translator means what? So whatever the program you write, it is called as source program. In the diagram you see, using language translator, it will be converted to its binary version, that is machine language version. That version we call it as object program or object code. So there are three types of translators: assembler, compiler, and interpreter. Assembler is the translator used in assembly level language. Where in the assembly level language, we have discussed that there are commands given in the English like simple words instead of machine level language codes, where these codes are have to be converted back to binary so that computer can understand. So to do this translation, we use this assembler. So assembler will check for the syntax and semantics of the code, then it will translate it into its equivalent machine code, and also known as object code. So here the following are some of the generally used assemblers: TASM, Turbo Assembler; MASM, Microsoft Macro Assembler; AS, Unix Assembler; FASM, Flat Assembler; NASM, Net Wide Assembler, and many others. Remember these shortcuts, it may come in MCQ question. So assembler definition is a system software which translates program written in assembly language into machine language. So assembly level language program, through assembler it will become a machine program. So compiler, in the sense, this is the translator which will be used in high level programming languages, HLL, where the source code will be converted into machine code, which is called as object code. The compiler will check same thing, source code of the for syntax and semantic errors. If everything is right, line by line, then it will produce the executable file only if it is free from all errors. So definition of compiler is what? It is a system software. You need to remember all these definition properly, right? One more question may come. System software that translates source code written in high level language into object code, and which is in machine level, in machine language. Interpreter is what? Here, this is another type of translator used for some of the high level programming language. Let us see what it is. So as discussed above, the process of compilation consumes a lot of memory, and so system with less of amount of RAM always prefer interpreters, where the source code is analyzed line by line and executed immediately, and it reduces the need of larger RAM capacity. You don't require larger RAM. Source level debugging also becomes easier when compared to the compiled one, but overall execution time is more compared to a compiled program, because during execution we require both source code and interpreter, and the translation is required afresh. This invites security problems also. And all system software will use compiled program because it does not require recompilation of source code. The earlier versions of COBOL, Fortran used interpreters, but nowadays we have all compilers only. The latest languages, all they use compilers. But web languages are mainly dependent on interpreters instead of compilers, right? Java is an interpreted language, where JVM, Java Virtual Machine, for running web applications, C++, web applications, and languages like C, C++, Visual C++, they are compiler dependent language, right? Due to their inherent applications in it. So this is the definition of interpreter. Utilities, right? Utilities are those helpful programs that assist the computer by performing usual functions, like housekeeping functions, we can say, like backing up disk, scanning, cleaning viruses, arranging information, like that. So they are generally called as application-oriented ready-made system program. The application-oriented ready-made system programs, not application programs. So some of the utilities are like text editor, backup utility, compression utility, disk fragmenter, antivirus software. These all you can see in the control panel of the Windows program, right? So in that we have linkers and loaders, where a source program written in high HLL may contain number of modules or segments, right? So for the program to be executed properly, the modules are to be linked properly, right? Linked properly, and the various library segments included, so that execution of the program is sequential. This operation is performed by software called as the linker, right? See, linking modules in the sense what? Like different units of the program which will be doing different operations. They all have to be linked properly. That will be done by link. For example, you take example of school, right? there must be a, see what principal will do, right? So he will instruct the clerical section to take the admission first and allot the sections for them, right? After that, for every class and sections, principal will allot teachers as, and they'll allot the timetable also. So as per the timetable, as per the periods, they have to take the class, right? And when the sports period is there, sports teacher will come into the action for conducting sports. When students go to the library person should give all the textbooks, taking and giving should happen. That means what, all these units are linked with each other. They are acting on their, when their turn comes, automatically they'll start doing their operation. Like that in the computer also, this kind of coordination is required, linking is required, it's done by link. So this is the definition. A linker is a system software which links the modules or program segments together so that they can be executed properly with proper reference. The output of the linker is a single program, which includes all the modules and the entire library required for execution. So the linker is thus responsible for generating the executable code of the program, right? So once an executable program is generated, someone will have to load that program into the main memory so that your CPU can execute or process it to produce the final result. And that is done by another system software called loader, right? It actually places the object code from secondary memory into the primary memory, that is RAM, and starts the execution. That is what loader. So functions of the OS, what all it will do? OS, as I said, it's a very important one. So let's see, it will do very several and very complex operations in the system. So here OS is a large and complex software consisting of several components, right? So to understand, see OS, you go to the Google and you write how many lines of code written to develop the Windows 11 or Windows 10 software, how many lines of code is written to develop Android, or for iOS, you check it out, you will come to know how much large program they are, how much complex also. Each component, see, simply we are operating the mobile very easily, but behind that Android, what they have developed, what iOS they have developed, we are enjoying the using computer, we are playing game, we are using it for different work, but behind that, the OS Windows, what they have written, no, you just check out in the Google. I don't want to tell here, you only check it out, right? So how much large program they have written to make us to work in the computer so easily, right? So here, each component of the OS has its own set of defined inputs and output. Different components of OS perform different tasks to provide overall functionality of the OS. The main operations are memory management, allocating, freeing memory, reallocating memory, keeping track of memory usage. Process management, so they handle these all operations, these all points, right? Check it out. So process means it's a defined as a program in execution. Device management, right? Open, close, write device or drivers, communicate, control, monitor device drivers. All devices will be handled by OS. See, when you insert the pen drive, it comes in my computer. Who will do that? Who will help you to do storing the data into pen drive? Who will help you to retrieve the data from pen drive? All by OS. Behind every work in the computer, what you are doing, OS is working, right? So file management, all what you are doing in the my computer program, creating folder, copying file, renaming, deleting, all it will be done by file OS. Protection and security is also given to you. Firewalls are there in the computers, right? And user authentication, when you are starting the computer, username, password, it will ask. And to control the file access, they create the file attributes like read, write, encryption, backup of data. They all it will do. User interface, command interpreter will be there, so that you can computer user and the computer hardware, there will be an interface. The user interface is a set of commands or a graphical user interface, that the Windows what you are using now, right? That's a user interface or command interpreter. Without this, you will not be able to work with the computer. And types of OS, we have single user, multi-user, batch operating system, multi-programming operating system. In that, multitasking, multi-user, time sharing, real-time, distributed OS, network OS, multi-threaded operating systems are there. Single user means, so this OS will be used by only by one user. So the OS allows only one user to share the system resources, including the CPU. These are mainly OS configured for the use of desktop graphical. So now we will see different types of operating systems one by one. First one is single user operating system. As the name itself says, single user, only one user to share the system resources, including the CPU. Right. These are mainly the OS configured for the use of desktop personal computers and laptops, which will be used usually by one user. DOS, these are the examples: DOS, Windows 95, Windows 98, Apple Macintosh, etc. are examples for such systems, right? All others except DOS has the ability called context switching, allowing it to operate on multiple programs, that is Windows or applications, except DOS, right? All other, they can work, they can switch, context switching, allowing it to operate on multiple programs. So batch operating system usually allow little or no interaction between users and executing programs. Users and executing programs. It requires programs. Data, and necessary commands, that is job control language. In short, we call it as JCL, to be submitted in the form of a job. It has a better potential for resource utilization compared to simple serial system serving multiple users. This is well suited for application with a large computation time and no user interaction, like payroll forecasting, statistical analysis, and the large scientific number of crunching programs are the example for its usage. User need not to wait during its execution, right? So where this batch operating system works on the basis of F5 or FO, that is first in, first out order. The main drawback is what? These are non-interactive mode of execution and offline debugging. Examples are IBM System Bar 360 OS, which is also called as OS Bar 360 for IBM System 360. It's an example for batch processing operating system. In DOS, we can emulate the batch processing using .bat. Batch processing in the sense what? Simultaneously executing multiple commands. That is in the DOS, there will be some files called as .bat, stands for batch files, where we used to store more than one DOS command. So when we execute that batch file, all the commands present in it will be executed one by one. That is batch file, right? So multi-programming operating system. Multi-programming in the sense it is the capability of the CPU to execute two or more programs concurrently, that is simultaneously, right? Simultaneously, CPU can execute more than one program, and this capability is accomplished through the OS. Essentially, two or more programs are Essentially, two or more programs are stored concurrently in the primary storage, and the CPU moves from one program to another program, partially executing each in turn. See, that means what? Multi-programming in the sense In the primary memory, more than one programs will be present, two or more programs. Then how CPU can work with more than one program simultaneously? See, for example, assume that what we are doing is we are giving some task to the CPU. One side addition, one side subtraction, one side multiplication, one side division, right? So all the functions I'm giving at the same time to the CPU to give the result. So internally, all these things cannot be handled at the same time. That is not possible. But what it will do is, in turn, right, it will not see addition, subtraction, multiplication, division, all four operations have given. All four operations cannot be executed at the same time. But in turn, what it will do is, assume that add function for few microseconds, it will work. And then complete operation is not done. Little it is handled, then it is switched to subtraction. There little processing is done, then switch to multiplication. Again, little processing is done in the multiplication and again switch to division. So like this, it will continue its operation, right? So like this, multi-programming operating systems will work. But in turn, the partial execution, what we have, right? So that switching from one program to another program, the delay what we have on which the particular task is being considered, the time is very less, right? So the person who is using the computer feels that the CPU is doing his task only. It is concentrating completely for his task only. But internally what? It will be taking care of all the tasks. So only one program is executed at a time internally, right? Hope it is clear. Multi-programming. Multitasking operating system means it is distinguished by its ability to support concurrent execution of two or more processors. See here, multi-programming is different from multitasking. Multi-programming is what? More than one program will reside at the same time in the memory. Those multiple programs execution, it will handle it by using multi-programming operating system. Whereas multitasking in the sense what? This is what? Performing more than one or task, right? Performing execution of one or more processes is what multitasking. A processor task is an instance of a program in execution, right? Multitasking is usually implemented by code and data of several programs in memory simultaneously and multiplexing processors and I/O devices among them. Multitasking is also called as what? Context switching. Multitasking usually refers to single user. Windows 98 and some real-time systems comes under multitasking, right? So multi-user operating system in the sense, as the name itself says, these operating system will work for multi-users. See, multitasking with a sophisticated memory protection and enforcement of concurrency control among processors, which try to access shared resources such as I/O devices and files, are called multi-programming operating systems. Since it supports multiple users, it is also known as multi-user operating system. Here, multitasking with the sophisticated memory protection and enforcement. Sophisticated memory protection. Enforcement of concurrency control among the processors. Right. Concurrency means, remember, simultaneously, simultaneous control among more than one process which try to access shared resources such as IO devices and files are called multi-programming operating system. In the multi-programming operating system, what happens is simultaneous control among more than one processes which will be trying to access the shared resources. Any input device or output device or files, more than one process will be trying to access it. But for whom it should be given, for whom the access should be given of shared resources such as IO device and files, that will be that simultaneous control among these kind of processes will be handled by multi-programming operating system. Since these operating system supports multi-users, that is why it is also called as multi-programming operating systems are also called as multi-user OS. It creates and maintains individual user environment. Individual, see, even when there are multiple users in the operating system, every user separate environment will be maintained. Separate authentication, login authentication, separate security levels or privileges we call, right? For every user, it will be provided. Due to these reasons, we can say multi-programming or multitasking implies multitasking, but the converse need not be true, right? We have systems with more than one processors. Each processor can be multitasked, right? See, some systems, see, right now we have what computer I'm using now, it is having only one processor. But where there is a requirement of heavy processing, sometimes multiple processors can be placed in the computer. See, for example, assume that there is a goods train and there is a very heavy weighted materials in the bogies, which cannot be handled, which cannot be moved through one engine. In such case, what happens? Sometimes even they attach multiple engines also. Like that, based on the number of processing tasks to be processed, right? Based on that, some systems can have more than one processors also, right? So each processor can be multitask. So in purely multi-user or multi-programming system, processor is also a resource. That is also a what? It is a resource. Time sharing system. Time sharing is a popular representative of multi-programming and multi-user systems. Large CAD and text processing systems belongs to this category. Good terminal response is one of the main objective of such system, providing an illusion of total dedication, right? So in this time sharing, in the sense what time slicing or round robin scheduling algorithm will be adopted in time sharing operating systems. So the best example for this is Unix, Windows servers, right? These are the examples for multi-programming, multi-user and time sharing system. See, that means what? Here, assume that there are task 1 called as T1, task 2, it is T2, task 3, T3, task 4, T4. There are 4 tasks. When I give these 4 tasks to the operating system, right? So what happens is, here, assume that the time allotted for T1 is 5 milliseconds. For this 3 milliseconds, for this 4 milliseconds, for this 6 milliseconds. That means when the processing of T1 starts, whatever may be the task present in the T1, it will be processed only up to 5 milliseconds. Even still in the T1, some more work to be done, still pending is there. Operating system doesn't worry about that. After 5 milliseconds, immediately it will be switched to second task. second task will be executed for 3 milliseconds. After that, still pending work is there in T2. T2 is still not completed. No problem. It will go directly to T3. Right. It will go directly to T3 and T3 will be executed for 4 milliseconds. And after that, it will switch to T4 task, which will be executed for 6 milliseconds. And after that, it will come back to task T1 again for continuing with the task T1 where it had left earlier for the next 5 milliseconds. In that next 5 milliseconds, the task may complete or not complete, right? Immediately after 5 seconds, it will go to the task T2. This is called as what? Time slicing, or this is also called as one more name for that, round robin scheduling program. See, round robin. After completing this T4, again come back to T1, T2, T3, T4. Again go to T1, right? So like this, what happens is every portion will receive some time slot. So Unix is the best example for that. Real-time systems are used in environments where a large number of events, mostly external to the computer system, must be accepted and processed in a very short time or within certain deadlines. Such applications include industrial control, telephone, switching equipment, flight control, real-time simulations, and military applications. So in all these places, real-time systems will be handled. We'll have one example. So here, assume that real-time systems, assume that some factory is there. Say, we'll assume that steel factory, right? So you might have seen or heard the raw material coal, right? It has to be melted at a very high temperature. Sometimes if you see in YouTube or in the Discovery Channel, uh, mega factories and all, we see that melted coal, no, it will be flowing like a water in a channel, right? Assume that, think that when this temperature, right, increases to some extreme range called as X, right? We don't know when it is going to reach to this particular level, right? In what day, in what period, in what year it is going to come, that no one doesn't know. When it reaches to that, immediately, right? Immediately alarm should be done. For example, right, indicating that the staff should get active, right? Then certain messages have to be messaged to the certain department who are going to handle such kind of critical situation, right? A message should be messaged, right? So, and one more is what, immediately to cool that automatically, if anything is there, those systems have to be started automatically, right? Automatically they have to be started. Such kind of things, to handle such kind of thing, real-time systems will be there. Assume that in this section, if I'm appointing one person who has to monitor this extreme level of temperature, when it reaches, that fellow has to do all this work, right? But we don't know, factory has started 25 years ago, but till today, not even one time this situation has occurred. That means the employees working over there, they came to one solution that this kind of thing will not come only. Simply just for precaution purpose, they have appointed me for this section, right? So they'll be ignoring the job. That is why in these type of section, what they do, they adopt a real-time system where whenever that system will be working all 24 hours, right? So that whenever that situation occurs, immediately that system will take care of all this. That is one general example, right? So we have Linux OS, Windows CE are the example of real-time operating system. We have distributed operating system. It is a collection of autonomous computer systems capable of communication and cooperation via their software and hardware interconnections, right? If we have n system in a distributed environment, then the distributed operating system helps us in balancing the load by sharing processors, I/O devices, and memory, etc. Without the knowledge of user, the end user will get his output on his terminal. This has very reliable mode of operation, right? So here for distributed operating system, centers of a bank are a classical example of application of distributed operating system. See, that means what? Assume that there are n number of systems in the distributed uh, operating system or environment, right? So there, whatever the loads are there, right? That means what? The task of processing the jobs, operations, right? Those when the load increases, right? Without the knowledge of the user, internally distributed operating system, as the name says, distributed, right? It will distribute the excess load in multiple processors. They will distribute the load in multiple processors, and then the final result will come in time. But user will not be knowing that the result what I'm getting. So it was, if that task was handled by only one process, then it uses to get late. But internally, because of this task executed by multiple processors, this result has come in time, but the user will not be having any intimation regarding that. It is something like, assume that, right? Assume that some paper valuations are going on, right? Paper valuations are going on. Few second year paper valuations are going. There were 1,000 PU lecturers, right, who were doing paper valuation. Suddenly in them, if 1,000 PU lecturers every day, if they do valuation, in 15 days, the final results can be given to the students. But 500 lecturers in them, what they did is they sat for strike saying that we want more salary, we want increment in our salary. You increment it, then only we'll sit for valuation, otherwise we'll not do. Now, education minister is what having pressure now, right? So only 500 lecturers are there, who now remaining 500 they have sat for strike, right? Now, without here these peoples are doing strike, we have only 500. The education minister, what he did is he managed something inside the system only. Means what, within those 500 lectures only, he did the meeting and he convinced those 500 people to do 1,000 lecturers work. That means another 500 people's work have to be done by this 500 only. They agreed, right? Some agreement was done. So then they completed, they took some extra time and they completed the valuation task in 15 days only. And these 500 lecturers, no, they were right. So they were very uh, they were not believing how this was completed in time only by 500 people. That means without the knowledge of these people, internally the extra load what it was there, it was distributed between these 500 people and the task done in a right time. Students were not knowing all those internal things, but results came on time, right? Like this, distributed systems will work, right? And we have network operating systems, NOS, we call it's a collection of software and associated protocols that allow set of autonomous computers which are interconnected by a computer. See, network means what? Group of computers, group of autonomous computers which are connected with each other through some media is called as computer network. In that, one computer will be the main computer, remaining computers will be the subcomputer. The main computer, we call it as a server, and the subcomputers, we call it as a node or clients. So in the server, there will be a one special operating system called NOS, Network Operating System, where that network operating system will be making the communication between server and the client, right? That is a network operating system. And this is very convenient and cost effective manner. In a network operating system, that users are aware of the existence of multiple computers and can log into remote machines and copy files from one machine to another machine, right? See, resource sharing will be there, program sharing will be there, file sharing will be there, right? And each computer will be having its own private operating system. But along with that, when they want to communicate between the machines which are present in the network, that time what happens is this network operating system will come into the action, right? So the all files movement, whenever you are sharing some files, right? So it will be shared with another computer without the knowledge of user. Assume that there are 10 computers connected to the server and one printer is there which is attached to the server. So any a user who is sitting in these 10 computer, if he say print, it will be printing the same printer which is attached to the server, right? Like this, even resource sharing can also be done, right? So operating system based on this NOS are Microsoft Windows NT technology, Unix, and its flavors like Novel NetWare, Cisco iOS are some of its represented. We have multi-threaded operating system. Thread means what? It's a sequence of instructions within a program. Program is a set of instruction. In those set of instruction only a sequence of instructions. It's a thread. A program or process may have many threads which share the same code section, data section, and other OS resource. In other words, it provides many logical paths through the program to be executed simultaneously, right? So for this concept, Sun Solaris, Windows 2000, multi-threaded Unix, Linux are examples of such systems, right? So functional features of commonly used operating system. The operating system in general provides user interface to interact with the computer. That is very important. Operating system is doing all these operations, but how user can communicate with operating system, that is through the user interface. Now you see on the screen what you are seeing, this is all user interface. I have a button called as a start. With it, so I can start any program, right? In those programs, I see when I start MS Word, in that I can do some operation because interface is there. So those interfaces are of two types. One is CUI, GUI. CUI stands for command line user interface and the GUI stands for graphical user interface. Right. Now this CUI in DOS it was there. Now also I can show you. Go to the start and type CMD and press enter. This is the DOS. Right. Command user interface means what? You can do the operations only by typing the command. There is no alternate way for this. Right. So here the cursor where it is blinking, it is showing you C:/user/Lenovo. So this is what? Command prompt. It's called as command prompt, where in front of that we are going to type various command. And these are character based interfaces. These are also called as character user interfaces. Right. Hence it's a non-graphic, no graphics, purely text-based user interfaces. When we were operating these MS-DOS and all, like when we were in college in 1992 and all, we were having this DOS only as an operating system. That time even mouse was not there. Where we used to do all the operations just by typing the commands in the DOS. But later on, a new interface was introduced called as GUI, graphical user interface. So which was first introduced in the year 1984 by Apple with the Macintosh operating system. So GUI in the sense what? It's a completely graphics based. Now what Windows, Android, iOS we are seeing, they are all GUI based interfaces only, but original GUI was developed by Apple company, right? And the Apple with Macintosh. So all commands, icons, operations will be done through the mouse and keyboard also, both. So that will be very much easy. Windows is the very popular GUI. By seeing these windows only, even mobile operating systems are developed. The common comparison is given. Here, for everything, the user has to type the command to interact with the computer. Here with the mouse, user is going to interact with the menus, dialog boxes, icons and all. User must remember all the commands. Here it is not like that. When you click on some particular command, so all menus, sub menus, icons, everything will be there on the screen only. So it will be user need not to remember all the commands. So everything will be on the screen. He can just use it. Mouse operation is not available for DOS, but here it is available. And operating systems, DOS. DOS is a single user operating system which was developed by Bill Gates, right? And Paul Allen, 1980, for IBM personal computer. PC stands for personal computer, where file management, creating file, writing file, deleting file, directory management like creating a directory, changing directory, searching directory, deleting directory, memory management like allocation and deallocation of memory, command interprets commands and executes DOS functions, utility programs, right? Like this, there were more features. Unix operating system, which is developed by Dennis Ritchie and Ken Townsend on a DEC in 1985 by Sun Microsystems, where with this, you can handle hierarchical file organization, portability, multi-user, multitasking support facilities like kernel and shell programming, machine independent, excellent tools and tool building capabilities. Linux OS, so it is basically developed by a Finnish university student, Linus Torvalds. That's why the name of the software is kept as a Linux. So it's a open source software where anyone can download from Linux.org. It's not licensed one. It's an open source software, right? So it provides you all these facilities. Solaris, the operating system, is a free Unix-based operating system introduced by Sun Microsystems in 1992 as the successor to Sun OS. There was one Sun OS. Along with that, they introduced this. So advanced networking capabilities were provided to support wireless and high throughput networks. Facilities, zoning, security, user interface for internet browsers, media players, Office suite, managing hardware usage of particular application was there in Solaris. And Windows 7, which is the most recent client version of Windows developed by Microsoft company. So it supports you GUI, right? So all these different operations, features, facilities provided by Windows 7. Windows 8, these are the facilities which was introduced in 2012 by Microsoft Windows. And after that, mobile operating systems came out. Android OS, which is very popular nowadays, right? Earlier, it's a Linux-based platform for mobile phones, which is developed by Google, and it's an open handset plans OHA, coalition of hardware, software, and telecommunication companies. So Android was released under the Apache V2 open source license. Symbian, uh, so it's a operating system for mobile phones which used on Nokia advanced or data-enabled smartphones, right? Symbian OS is designed for the specific requirements of 2G and 3G mobile phones, right? Before Android, Symbian was there in Nokia and all. We have used it. Windows Phone 8. Windows Phone 8 is a mobile operating system developed by Microsoft, and it is the successor of its Windows mobile platform, although incompatible with it. Windows Phone 8 was Microsoft's answer to the flourishing smartphone world. Okay. So this is all about explanation about the fourth chapter. Thank you.